Chapter 8, Section 5 is on something called law of sines. Before we get into how this law works, we just want to understand what it's saying. This is the law right here. It says sine of angle A over side A equals sine of angle B over side B, which is equal to sine of angle C over side C. So we have a lot of different ratios or fractions that are equal to each other. We need to understand what these letters represent. The capital letters are angles, so A, B, and C. And then the lowercase letters are the sides opposite that angle. So if I see angle A right here, lowercase a refers to the side opposite it. Here's angle B, side B is opposite. There's angle C, side C is opposite. So what this says is if I know maybe three kind of important measurements, I can basically find a fourth. Generally, we only use two of the fractions at a time, and it's just a kind of a handy way to reference that relationship. So why does it work? We're going to add in just a little bit to our picture here. Okay, that's the height of this triangle. And I'm going to write out a couple of relationships that I can see within that triangle and involving the height. So if I were to stand right here at angle A and I look at this right triangle right there, sine of angle A would equal h over b. So sine of angle A would equal h over b. And I can basically solve for h if I want to. We don't understand y quite yet, but we could say that b times sine of angle A should equal h. Okay, so that's one thing that we're trying to do. And then if I went over here and stood at angle B and I looked opposite, I'm going to say that sine of B is h over a. Now the hypotenuse in this triangle on the right side is a. So another relationship is sine of angle B is h over a. And again, if I were to go ahead and solve for h, it means multiply by a on both sides, I get a times sine of angle B equals h. Okay, so I have these two relationships now, one right here and the other one right there. They both equal h. They're both referring to the same triangle. So that tells me that, let's see, how do I want to write this? I want to go b times sine of angle A has to equal a, lowercase a, times sine of angle B. Okay, the two underlined red pieces have to be the same. And then if I were to do a little bit of algebra, so I'm going to divide by a on both sides. And I'm also going to divide by b on both sides. Okay, over on this side, the a's would cancel off, and over here, the b's cancel off. And I'm left with that relationship that we see in the law of sines. That sine of angle A over side A has to equal sine of angle B over side B. And then we'd have to kind of tilt our triangle, look at it from a different perspective to figure out how sine of C over side C fits into this. But it is possible to do that. But that's just kind of a one way that we can show why the rule works. But for the most part, you're not going to be asked to explain this one. You're going to be asked to use it, which we'll see in our next two examples. So in this example, they tell us that we have a triangle ABC. They tell us something about the measure of angle A, the measure of angle B, and something about a side length, the fact that AC is 15. They're asking us to find side BC. So the first thing that I typically do, I just draw a triangle, and it does not have to be to scale. A lot of times my triangles will just look kind of like equilateral triangles. If I say this is A, and this is B, and that's C. Doesn't really matter how you orient it either. But let's put in some of the measurements that we know. We know that angle A was 48 degrees. We know that angle B was 93 degrees. Okay, they told us that side AC is 15. And we want to find BC. So I'm just going to call that X. Okay, that's what we're trying to find. So here's what I want you to notice. We know two of the angles. Okay, to find the third, if I had to, I know all three angles have to add up to 180. So if I go 180 minus 48 minus 93, I can figure out what that is. Sometimes that's helpful. In this case, though, what I notice is that I have the angle of 93, and opposite it is the side length of 15. And I have the same relationship here. I know the angle, and I'm trying to find the side length that's opposite it. When I see those opposite sort of relationships, that tells me that it's set up nicely for law of sines. So law of sines says, don't even worry about the letters so much, just realize that opposite relationship. It means sine of an angle. So I'm going to say sine of 93 degrees over the side opposite it, so 15. That has to equal any other sort of relationship like that I see. So in this case, I see an angle of 48 degrees, so sine of 48 degrees over the side opposite it. This is a true statement according to the law of sines. And so, just remember that sine of a number, sine of an angle is just a number, and so I can cross multiply and divide here if I want to. So I'm going to, in my calculator, type out 15 times sine of 48, and then take that answer, divide by sine of 93, and that should tell me what x is. So just cross multiply and divide. I'm going to tell you what the answer is, but you need to check this on your calculator. Make sure you know how to enter it in so that you can consistently get that. Now, obviously, algebraically, you could show this a little bit clearer, but I'm fine if this is the work that you show. You have your two fractions set equal to each other, and now you need to figure out how to cross multiply and divide. So if you did this, if you cross multiply and divide, actually type in 15 times sine of 48 degrees, hit enter, then divide by sine of 93 degrees, you should get about 11.16, and there are no units for this, but that should be our answer. So go ahead and try that one. Make sure you can get about 11.16. Okay, our next example is very similar, but in the end it's going to have one major difference. Now our triangle is RST, so again I just draw a triangle in there. I don't really worry about making it to scale. This will be R, S, and T. In this question they tell me that RT is 11. They tell me that ST is 18, and that angle R is 120. And we want to know what angle S is. So if you want to put a little X right there, we're trying to find X degrees, you could do that. The difference here is we're finding an angle, not finding a side length. But the same sort of relationship is still what we're trying to make here. So I'm going to look for across relationships. So I have 120 degrees, I know the side opposite it. I'm trying to find this angle, I know the side opposite it. This is set up for law of sines. I would say sine of an angle, so sine of 120 over 18, so the angle and what's opposite it, has to equal sine of a different angle, so sine of x divided by the side opposite it. Okay, so we're set up for law of sines. Again, the difference is we're trying to find an angle. So now if I cross multiply and divide, I'm going to go 11 times sine of 120 divided by 18. But notice what I'm going to get from that answer. I'm going to get sine of x. I'm not just getting x. So it's very important that you realize when you cross multiply and divide that you're getting what sine of x is equal to. Okay, so I'm going to quick type that into my calculator. Okay, I get 11 times sine of 120. Okay, hit enter, I divide that by 18, and I get about 0.529. I'll give you a lot of decimals here, 2377. Okay, we don't really want to round too much at this stage. So now we need to think, how do I find x? And this is that case where you would use inverse sine. Okay, your calculators often can kind of store your previous answer, so it's possible you don't have to write all this out. But we want to figure out what inverse sine of this answer is. And when we do that, we get about 31.95 degrees. Okay, so law of sines, you are looking for relationships across from each other in triangles. You're going to set up two into fractions. Two equal fractions, and generally somehow you are going to cross multiply and divide to solve the entire question. Just be careful when you're finding the angle that you take inverse sine at some point. We'll stop here. Ask some questions if you're not quite sure.